the derivative function, constant rule. If f of x equals to c, where c is a constant, then f dash x equals to 0. So that is what the constant rule is, and here we'll try to prove it, right? So when we are saying f prime of x, we mean derivative, correct? So what we are saying here, if we have a constant function, then derivative of that function at any point is 0. That's what we mean when we say f prime of x equals to 0, right? We're not saying at x equals to a, b, c, d, correct? Any point in the domain of the function. That's what we mean, right? So remember that if we have a constant function, then its derivative is 0. Now it's a good idea to prove it. So let's prove it for once, and this is what we are going to do here. So we'll use the basic limits definition, right? So f dash or f prime of x can be written as limit h approaches 0, right? F of x plus h minus f of x over h, correct? Now for our function, which is fx equals to c, what is x plus h? There is no x term in it, right? It's just a constant c. So at every point it is just c, right? So the value is c, right? You get limit h approaches 0. We have c minus c over h. Now c minus c is 0, right? So therefore f dash of x is 0 for any point. Well, it's interesting, but let's have a look. Why is it so? So let's say this is our coordinate system, and we have a function here, which is, let us say f of x equals to, let's say 5. Let's say this value is 5 for us now. What is the rate of change or slope of this line? As you know, it's a horizontal line, right? If it is a horizontal line, slope m equals to 0, correct? And derivative is basically slope, right? So there is no change in y value. As x changes, y remains same, right? That is what we mean by a constant function, c, right? So if we have a line, let's say another line, which is horizontal line, where this value, y-intercept, is c. C could be any real number. As you can see, change in y is 0 for any change in x, and therefore the slope is going to be 0, right? Or rate of change is going to be 0, or derivative will be 0, correct? That's how you should understand. So derivative of a constant function is always 0. So let's remember, derivative of a constant function is always 0. Is it okay? Remember that part. Now here is an example for you. Determine derivative of the function f of x equals to 3 pi square at x equals to 0. This is a test problem. It comes in test. And I have seen, surprisingly, many students make a mistake here. They treat pi as a variable. That's irony. Pi is a constant, just remember. So this is a constant function, and therefore you know what the answer should be, right? It has to be 0. It's just a constant, right? So don't treat pi as a variable. Come on. So remember that part, and purposely I have written it here so that I remind you once again that pi is a constant, maybe an irrational number. So derivative of this function 3 pi square at x equals to 0 is let me read, f dash x is equal to 0, okay? That is what it is. It's just a constant. So if you plot it, you will get it here somewhere, right? And that's what it is, correct? So 3 square is 9, 9 times 3 approximately, right? Around 30, correct? So that's what you'll get somewhere. A horizontal line, what I'm trying to say. And derivative will be 0, correct? So that's the answer. Thanks and all the best.